All right. So as Wayne mentioned, the title of this webinar is Maximizing PEX Benefits and Efficiencies. So the objectives of this time will be how to select a PEX system for your next project, how design and installation maximizes the performance of a system, and how PEX can maximize your labor and profit on a job. I'm Seth Larson. I've been in the plumbing and heating industry since 2013 with experience in international procurement, product development, and product marketing. And currently I'm a product manager managing the Viega PureFlow product line and the strategic direction of that line. So jumping into our topic today, we'll run through several topics, including an introduction to PEX, design considerations, installation types, maximizing profit, additional considerations, as well as a couple of industry resources that can be used as desired. So what is PEX? PEX is a polymer piping material used in heating and domestic water applications. The base material is HDPE, high-density polyethylene, and the process is known as cross-linking, which improves properties at higher temperatures. It was introduced and first made its appearance in Europe in the late 1960s, but was introduced in the North American market in 1984. So jumping into how would you choose PEX? There are some common designation codes that aid with your selection of PEX. And these are described by a 4-digit code that's often found on the PEX print line of your tubing, as shown in the photo here on the PowerPoint. So that first one is chlorine resistance. And the maximum value for that rating is a 5, representing 100% performance at end use at 140 degrees. The second one there is a UV rating, which denotes UV exposure that the product is certified for, and that can range from a 0 to a 3. And all of these ratings, if they're a 0, means they're not tested, FYI. So then a 1, a 2, or a 3 are ratings ranging up to 6-month UV ratings. Then the third one, the 06 that you see there, is for the hydrostatic design stress. That's based on a hydrostatic design basis, which is calculating your performance at a temperature and pressure rating. So the 06 represents 630 psi at 73 degrees. And this is one way to look at the different competitive PEX on the market and see the ways that the competition stacks up. So why would you care? For example, for UV ratings, you may be interested to know a UV rating for greater confidence that the product has a certain amount of resistance when it may be in the sun on a job site or in a distribution location. And you don't want to leave it out forever by any means, but you would have an assurance if your UV rating is a 3, for example, like the Viega PureFlow PEX, that you have a 6-month window of time. So if you experience construction delays or other issues, that can not be a concern on your mind. So what is another way to distinguish the different PEX on the market? Like we mentioned, high-density polyethylene is the base material, and that is then transitioned to PEX through a cross-linking process. Those 3 processes are commonly known as PEX A, B, and C. Now, this nomenclature is not a rating of quality or performance. It's simply referring to the different manufacturing styles. So that first style mentioned here is peroxide, known as the Engel method as well. and it's where peroxide is added to the base resin and cross-linking occurs during the extrusion process. The second, PEX B, is the silane process, and the silane molecule is grafted to the polyethylene, and that cross-linking occurs after extrusion by exposing the tubing to steam. This is commonly known as PEX B again. And then PEX C, electron beam, the tubing is extruded like polyethylene and then exposed to a radiation beam. So again, there are a variety of ways that this is discussed in the industry. One thing that's common is to say, well, one method or another is cross-linked at a different percentage, so that denotes a certain level of quality, but that's not true. Each of these methods are prescribing to the ASTM F876 standard and must be cross-linked to a certain degree to meet those performance requirements. So PEX A, for example, has a higher degree of cross-linking to reach that same performance requirement. So just because PEX B has a lower degree of cross-linking doesn't mean it's substandard. It just means that it takes less cross-linking to meet those same performance. So why use PEX? There's several reasons. The flexibility is faster installation. It's a lighter weight material. You can eliminate fittings. There's a degree of freeze resistance. It's not freeze proof though. It has a resistance to scaling, pitting, and erosion corrosion. There's reduced heat loss compared to metallic pipe. However, when installation is required, that still needs to be used. And you can make connections without chemicals, solvents, soldering, torches. So you do have several benefits there. Leaving the product on the job site, it's less likely to be stolen due to no scrap value. So there are several characteristics that are benefits here. So what are the common types of PEX fittings? We have that top one shown there is the crimp fitting, prescribing to ASTM S1807 or 2159. There's a clamp fitting, ASTM S2098. There you see the Viega Pure Flow press fitting, ASTM F877, and the cold expansion ASTM F1960 F2080. So often a lot of your benefits of a PEX system come down to the type of fitting that is used, whether it's installation benefits or its performance characteristics or ease of installation. Those are several of the benefits where they come into play. For example, our Viega Pure Flow press fitting offers the ability to pressure test immediately, which is contrary to the cold expansion fitting, for example. It also is one of the fittings that it's a fully assembled fitting. Everything's all together, so you're not fumbling with a crimp ring or a clamp or a cold expansion ring. So there's several benefits there, and we'll dive into a little later how that installation efficiency can aid your profit and your labor on the job. Often you're going to be transitioning between PEX and other materials, and those transitions can easily be made using many of the available adapters. So you can be transitioning from copper to PEX using a solder adapter, or even a press adapter, which Viega carries and is the only manufacturer of a copper press to a PEX press fitting. You could be using a CPVC adapter and transitioning CPVC to PEX. Or there are several variety of threaded adapters and push fittings as well. So those are several options when you may tie into an existing system, or you're looking to use multiple materials for performance or design characteristics on a job. Continuing on in our discussion today, and right now actually we're going to have a poll which you can answer quickly of what is your commonly used brand of PEX. So that'll pop up here shortly. Feel free to answer. We'll have a second poll question a little bit later in the presentation.
Hi everyone, Wayne just chiming in real quick. You should see on your screen a poll question right now. Go ahead and answer as you see fit.
Great. So moving on, we're going to discuss some design considerations when choosing PEX, because often there can be some trepidation moving from, say, a metallic system to a plastic system, and there are things to consider. And as PEX grows in the market, we are seeing it more and more be installed in commercial applications and not just residential. So some of the aspects that come into play with commercial systems are considering the design characteristics because of a slightly smaller inside dimension, or considering how to install a hybrid system with those transition fittings that I mentioned. There are other aspects like fire ratings, hanging requirements, chemical compatibility, temperature and pressure as you get into these larger scale construction projects. So we're going to run through a quick example that will give you an idea of just a window into what these differences, how they affect your consideration with PEX. So here you see a copper versus PEX dimensions table, and you'll see that on the outside diameter, your dimensions are the same. However, on the inside diameters, you'll see a difference. And that's where it comes into play, considering just the different pressure loss that can be considered with PEX. So a pretty common installation type is plumbing to a flush bank. So here you have a flush bank requirement of 12 gallons per minute and 25 PSI. Let's look at the PEX versus copper comparison. So with copper, you've got 65 foot of 1-inch copper tubing using 5 elbows, and you have your equivalent feet factor considered there for those elbows, added on to that total length of tubing. Then you're translating that into your pressure loss and your overall pressure loss for the full length of the tubing. With PEX, you have the same length of PEX tubing. However, you're able to eliminate those elbows and use bend supports instead. So that minimizes your pressure loss, even though you do have that smaller diameter, inner diameter, like we mentioned. You have your pressure loss and your calculated full pressure loss on the system. So comparing the two, PEX does have a slightly greater pressure loss. However, with your municipal supply coming in at 65 PSI, you just want to make sure that you're in the right pressure, flow pressure requirement. And you see that both systems coming in at 56 and 60 PSI for PEX and copper respectively work in this installation. So again, you'll notice though that we have elected to remove the elbows, and that's a common mistake that is made in design or installation, is that PEX is installed exactly the same as copper. And really, you're minimizing the benefits that you're getting when you're choosing a plastic system if you're not also installing it like it has some of those benefits, such as the flexibility aspect that reduces your fittings required. A few other things to consider is that the piping size methods do not change between copper and PEX. There's fewer connections, less pressure drop, as we mentioned. PEX can help eliminate connections in concealed locations. And PEX tubing with plastic fittings can have a higher maximum velocity, but local code may still limit that velocity in your design, so you just need to consider that as well. It's always wise to refer to your local AHJ as well as the manufacturer to just fully understand all of the recommendations when choosing a PEX system. So moving on to installation types, we're going to discuss four common actually installation types, and then why they are beneficial and how to make sure that they're matched to the right building. So those three types here are branch and tee, remote manifold systems, and home run or parallel systems. We'll also discuss hybrid systems, which is essentially just connecting two different materials in the same system and how those transitions can be made. So you do see here that hot water delivery, you're going to have your best performance in a parallel system. That's also where you'll see your lowest number of connections. And the fixture isolation is also graduated toward the parallel systems. Parallel systems is something that Viega pioneered, and through this we see a lot of benefits, and we'll discuss why those benefits matter here in a little bit. Branch and tee is the most common piping method. It's been used for a really long time, and it's most commonly used with metallic systems. However, we do see many people who use metallic systems, transition to PEX, and continue to install with branch and tee. And like I said, you're not maximizing all of the potential of a PEX system in that sense. So you are most likely to have a difference in pressure drop when multiple fixtures are used. However, there's a lot of knowledge with it. And you're going to have the highest number of connections. So a few things to consider there. With remote manifold, this piping method is similar to branch and tee. However, the branches feed various manifolds located throughout the building. The key here is that this is ideal in a situation where your fixtures are far away from each other. So there's definitely a time and a place to use remote manifold installation. So these manifolds will then say feed a bathroom group, for example. And it is an easy way to incorporate hot water recirculation. You'll see here a couple of our photos of Viega PureFlow Press remote manifolds that we offer in our product portfolio as well. The Homerun method. This is also called the parallel method. And this has a central distribution manifold that has individual hot and cold water distribution lines feeding the fixtures. You do have the least number of connections compared to the other methods. You're least likely for pressure drop from one fixture to another, and the best piping method for hot water delivery. You can install this quickly, very energy efficient. We'll even talk about the hot water wait time that you save over the course of your lifetime here in a couple of slides. And so something here, the benefit of using a home run method is the ability to use smaller sizes of tubing in your system because everything is individually fed. So those smaller sizes of tubing, that's less water in the system, less hot water to purge, and that's where you get your quicker hot water delivery. So a quick recap on these, again, just re-showing you the table here to discuss the benefits and kind of finding your sweet spot relative to the type of building you have. A case study where Homerun was used. Often Homerun is installed in single-family residential applications. However, there is a significant amount of it that goes into hospitality applications. So here's an example of a resort location where a quick renovation was required, and they chose Viega PureFlow PEX, and it enabled them to save 50% on their installation time. What they're often doing in a hospitality environment with a Homerun manifold is they're installing it in the ceiling panel of the facility, maybe between several different hotel rooms, and then feeding those hotel rooms with 1 or 2 mana blocks. This enables them, if they have a maintenance issue down the road, a leaky toilet or something else that needs to be replaced, that they're able to turn off only the fixtures that are having issues with it, only the rooms that are having issues, rather than disrupting an entire floor of guests. So again, I mentioned, why does this matter? This is the way you can maximize system performance in a variety of property styles. So home run systems result in less water volume in the system by 26%. That translates to less water to purge from your system when waiting for your hot water to refresh, especially if you're using, for example, a 3/8 tubing to some of those lower demand fixtures. Over the course of the year, this system design can save enough hot water for 55 showers. And then over a lifetime, we've done some calculations to determine wait time benefits. You may save up to 21 days of your life waiting for hot water. So that's a pretty significant stat when you think about the amount of time you're spending standing waiting at your kitchen sink or at your shower in the morning waiting for that hot water to come to the fixture. The fourth installation method is the hybrid method. And this is where you're using multiple materials. You can see here an example even where you're using our Viega copper pro press fittings, transitioning to a Viega mini block, which is essentially a smaller version of our Viega mana block. And then also a version where you have a larger branch and tee system with PEX tying onto a copper, a large copper run. This is ideal for high-rise buildings when the risers are high pressure and maybe you're tying into a pressure reducing valve and then you want to tie into PEX afterwards. And again, you see our copper to PEX transition fitting that makes it very easy with the same tooling system and system match jaws just to switch from material to material without torches, without solvents and multiple other fitting methods. Here's another example where you see our Viega mini blocks tied in with ProPress or CPVC even. And so hybrid system is a growing advantage as you see the advantages of running certain portions of your building in one material, but then running into units, say with PEX. Here's a case study in Scottsdale, Arizona, where they had an installation of Viega ProPress as well as PureFlow PEX, and the benefits included they were able to transition between these materials very simply with the same tool platform. And you know, as fixtures were getting moved around and they were going to different design tweaks, they were able to flexibly adjust those changes. It allowed for an agile installation of 500 guest rooms, a luxury spa, 240,000 square feet of gaming space. So a very significant installation. We have another poll question for you. And the other poll question is centered around what you'd really like to learn. And so you'll see that pop up shortly. Wayne, if you'll trigger that, and we'll make sure that we can focus our conversation on that. Also, just a reminder, feel free to be typing in any questions as you go. We'll have some time at the end to take those questions.
Sure, the question is up now. If everyone can direct their attention to the screen to select anything that that they see. One sec. Okay. All right, Seth, it looks like a lot of the people, let me just close this real quick so I can share this with you. Looks like a lot of people would like to learn how to design a PEX system along with the installation instruction.
Great. So the next topic we have is maximizing profit. Here's another example, a scenario we will run through. Imagine you are a contractor and you're quoting to complete an existing bathroom rough-in. And you're rerouting some overhead copper lines, have your break-even identified here, some markups identified, and imagine if that project took an extra hour, for example. You would lose $300. That was your break-even. So that extra hour, you're losing an extra $300 because it wasn't in your quote. So that drops your profit from $374 to $74 on the whole job. It's an 80% decrease in profit, which is pretty significant. So what are some ways to be aware of this? How can you be careful about really guarding your profit? One way to do this is to be really careful about the fitting system you select. Viega systems are designed to be installation efficient and very consistent every single time. So you'll see here a time study that was done between Viega PureFlow Press and cold expansion. And this was a simple shower valve installation, but the cold expansion system took over double the time to make the connections and get the shower valve installed. So our connection, again, because it is fully assembled, you have a system match tool that's consistent every time. There are a lot of benefits that come into play there with guarding your profit, maximizing your workforce, and being able to move on to the next job. Another financial benefit, our fitting is able to be pressure tested immediately. Other fittings such as cold expansion or CPVC solvent weld cannot be pressure tested immediately. And those wait times vary from system to system. Some of them range up to 24 hours even. So imagine another scenario, a multi-floor installation where you're installing every single floor, but you do one floor and then you pressure test before moving on to the subsequent floor. So say you finish the floor installation of all of the potable distribution lines on a Thursday, and with a solvent weld or a cold expansion system, you're waiting until the next day to do the pressure test, just to make sure all the system has contracted with the fittings or cured with the solvent weld. However, imagine you installed a Viega PureFlow system, and you're able to finish the job halfway through the day on Thursday, and you've got time for your pressure test that afternoon. Rather than waiting until that entire next week, the following Monday, to continue on the next floor, you can continue on Friday. So it's another example where you're maximizing your labor. You have a quicker installation. You have more buffer in your schedule to accommodate other delays. Those are the factors that really matter when you're choosing a PEX system, when you're choosing a fitting system. We're going to move on into additional resources, and here's where we're going to get into a lot of the installation and design aspects that are considerations with PEX relative to hanger spacing, fire stopping, a variety of aspects. The example earlier with the flush bank is a great example of installation considerations as well. So there are a variety of hangers for PEX, including clevis and trapeze hangers that you see pictured here. Often these will be supported with a threaded rod, and they should have rubber or foam lining when they're directly in contact with PEX. However, if you have a PEX support tray, which gives PEX the same rigidity as a metallic pipe, you may not have to use that same rubber or foam lining. We do offer galvanized PEX pipe trays to increase that hanger spacing. So because PEX is a polymer system and it has a greater degree of flexibility than metallic systems, the hanger spacings are shorter and require more hangers that increases your labor. However, with the use of these pipe trays, it takes your hanger spacing back to the same of that metallic system. So you can minimize those extra hangers. With the trapeze hangers, this is great for multiple runs that are going in a similar direction, and you may use different clamps that tie into these unistruts. As you can see here, there are 3 different types of clamps shown in the picture. Another idea for hanger installation can be the ceiling tubing support. It's used for multiple runs, often with small diameter tubing, if it's going to a bathroom group or other small fixture groups. You do need to use a tubing insulator, and the reason for this, similar to the reason for the foam and the rubber on the clevis hangers, was as the tubing expands and contracts, that rubbing on a metallic hanger over time can have a negative effect on the tubing for the usable life. Another option could be lock clips. Those are used for individual runs of tubing, as you see on the bottom photo. They're made of plastic and offered in sizes 1/2 inch to 2 inch. How about with risers and tubing support runs? As you're going vertical, floor to floor, there are a couple different things to consider for cold and hot lines. For cold lines, use a clamp above the floor at every level. For below the floor, use it every 4 stories. However, with hot lines, you're using that clamp at the floor every level again, but below the floor only every other story. If you're supporting tubing runs, again, this is horizontally, you have to be at 32 inches on center for sizes 1/2 to 1 and 48 inches on center for sizes 1 1/4 to 2. But as previously mentioned, a way to increase that hanger support size or distance is to use those metallic galvanized support trays that Viega offers. What if you're installing PEX in a slab? In general, PEX can be installed in a slab. A good practice is to avoid having your fittings in the slab. However, if you do, Viega has a special coupling tape that can be used. It is a self-adhesive tape, and that ensures that you're not using a non-approved tape that where the adhesive may attack the polymers in the pipe or fittings. So that always should be considered as well. For entry and exit points of the slab, those should be sleeved to prevent shearing. And the tubing should also be sleeved as expansion joints. You see that third graphic down from the top. Another option, you see the bottom photo, is to use corrugated sleeving for PEX as well. Viega offers a corrugated sleeve for PEX tubing. It's already pre-sleeved, ready to go. And the benefit here is that you can put this sleeving with the PEX in the slab, and if you have repair or remodel issues down the road, then you're able to quickly pull that from the slab, pull the tubing out of the sleeving, and replace it as necessary. That prevents you from having to excavate dirt or chip up concrete if you have an issue down the road. Expansion and contraction. There is a difference in expansion and contraction between metal and plastic. So here you see that PEX expands 1.1 inches per 100 feet per 10 degrees of fluctuation, whereas copper is on a much smaller basis. PEX will expand at a greater rate than copper tubing. That must be considered. And so here you see some expansion offsets that can be installed. Those should allow for free movement, just as you see those temperature fluctuations, that the tubing can move freely and not be compromised. This is again the reason why you don't want a metal on plastic hanging situation, because that rubbing could cause damage over time. If you're installing PEX tubing in a plenum, this is again showing the use of those metallic galvanized pipe supports and the installation into a clevis hanger. You need to make sure that all of these components are ASTM E84 listed. That should include your tubing, your fittings, your galvanized pipe tray, your insulation as well. And all of these things in conjunction enable you to have a traditional hanging method. And you want to follow the manufacturer's installation method in this case as well. Fire-resistant construction. PEX tubing is listed according to industry standards to be used in fire-resistant construction. According to ANSI and UL 283, ASTM E119. And here you see some assemblies here from the Viega PureFlow installation manual, where it identifies what those assemblies might look like. The standards do address wood frame and non-combustible concrete and steel construction, so that's something to take into consideration. Fire stopping. So as you are penetrating through walls and other surfaces, you need to consider fire stopping just as with other systems. So the key here is to make sure that those fire stops are used, are compatible with PEX. If you have a question about that, you can always email into Viega technical support and ask about specific fire stopping and chemical compatibility of those systems. So it could be a use of caulking, a wrap, or a collar. And the fire stop should be approved by the PEX manufacturer and or the fire stop manufacturer. So it's important to make sure that these are compatible with each other and that that you're consulting with test assemblies to make sure you're doing it the proper way with installation. Chemical compatibility. So PEX is intended to be used for hot and chilled hydronic water distribution as well as hot and cold potable water applications. One way that it's not supported is compressed air. This is an application outside of what's typically supported. Another thing with chemical compatibility that you should consider is the different materials that may come in contact with your PEX system on the job site, including caulking. Like we mentioned with fire stopping, you want to make sure that those materials are not attacking one another. Spray foam, one of the issues here is the heat that can be generated when it's installed and when it's expanding. Fire stops. Many are compatible, but again, consult with the manufacturers. Heat tape, that can be used when freezing is a concern, but it's again something to be aware of and make sure the approvals are in place. Pipe insulation, fiberglass, cellulose, other types. Like we mentioned earlier, just because a PEX system has a lower level of heat loss than a metallic system, you should still be consulting with local codes about installation practices and make sure that you're not installing an installation that will attack the product. Pressure testing. PEX can be tested with air or water, so while it's not approved for a compressed air installation, you can test it with air, and it's advised to test it with air when you're in a freezing condition area. The maximum pressure is 100 PSI, but always check with your local AHJ. And then there's several leak detectors that can be used, including Odie's all-purpose leak detector, Mega Bubble, Snoop Liquid, and others. Those can also be submitted for chemical compatibility via our technical services department. And as you're designing your PEX system, what are the temperature and pressure considerations? The PEX operating parameters for domestic water are 160 PSI at 73, 100 PSI at 180 Fahrenheit. And then for hydronic heating, it's a little different, 80 PSI at 200 degrees Fahrenheit. Viega, as well as some other PEX manufacturers, carry PEX fire sprinkler fittings and tubing. And these are products that are approved for UL 1821 fire sprinkler protection for 13D application. Viega's system is approved for 1 and 2 family homes only. Our metallic systems are approved for other applications, but this is just our PEX system, and those performance parameters are 130 PSI at 120 degrees. So it's always important to know the differences in these different installations so that you're making sure that the system matches the performance requirements. Wrapping up here, we have a couple more slides discussing resources, and then feel free to type in those questions as we come to a close here shortly. Viega is a member of the Plastic Pipe and Fitting Association, as well as the Plastic Pipe Institute, And this is when member companies come together and we work on multiple resources to support the PEX industry. So one option here is the PEX Design Guide, available at the PPFA website. There's a design calculator also. It's available at the Plastic Pipe Calculator website. And then there are continuing education courses that have been developed through member companies at PPI that are available through Red Vector that qualify for continuing education requirements. Additionally, feel free to visit the Viega websites as well. Either of these websites offer tremendous amount of information on the benefits of the Viega PureFlow system, the product offering, and it will show you how you will really notice how our PEX is built with unbelievable strength and incredible speed of installation and mind-bending brilliance related to our fittings. So again, I hope that you've enjoyed the webinar. Thank you for your attention. And make sure that as you're going about designing and installing PEX, that you're considering all of these aspects, making sure that you're choosing the highest performance PEX, that you're looking for those ratings that denote a certain level of quality. And then don't forget to consider what's the time required to install these fittings and what's the benefit of that. Maybe you're saving a few hours on a job site. Maybe you're pressure testing immediately and getting on to the next floor. Or maybe you're just maximizing a shorthanded labor force that you have on your team. Thanks, everyone. Have a great day.